So what is a big data? Big data, actually, let us see what are the things for big data professionals like big data and Hadoop professionals. And one moment. And today's agenda will introduce what is big data and why we have to learn big data, and what are the how is it important for a IT job holder, and what is the job market, and also we'll review the course contents, what we are going to discuss in the course. We'll review it, and we'll also see the prerequisites and the ideal trainees. Ideal trainees can be database administrators or database developers or programmers or developers who are developing applications in other languages such as Java or Python. So they can learn Hadoop and Big Data. So this is a scenario like, so the big data skills are like Apache Hadoop and Apache Spark. Spark is a tool. It is it is used to design applications on the top of Hadoop. Hadoop is basically a framework. It's a sort of, you can visualize it as a operating system. So it is installed on the top of Linux machines basically. So is a sort of it will help you to store the data and process the data and create the files, etc. It has its own file system called as HDFS. So then you can visualize the data. So data visualization tools are there, and NoSQL. Uh, this is for database database processing. Like here in Hadoop environment or in big data arena, we have data. The thing is, normally we have relational database management systems wherein the data is structured. So you have a definition for the data to store. Say for example, employee details. You have employee ID, employee first name, last name, salary, job ID, etc. Salary, department ID, etc. So that has been structured. The data has been structured. But in big data arena, the data is structured, unstructured, and semi-structured. There are three categories of data. So the challenge is we have to process structured data, and it is relational in RDBMS, relational database management system. The data is structured. We use SQL or SQL to process the data, to retrieve the data. So we have NoSQL, that is from Oracle actually. Oracle. So NoSQL is used to process the data, to store the data and process. So process unstructured data, semi-structured, and then we have structured. So it is very easy to process the structured data, but the challenge is to process the unstructured data. Unstructured data means the data is coming into the system in the form of videos, movie clips, and sound waveforms, etc. Anything, pictures, etc. So we have to process such data. So we use NoSQL. So this is also one of the big data skills and data science. So our major concentration is on Hadoop, Apache Hadoop, and of course, data science is a separate stream. We have separate languages, but in Hadoop environment also, we can achieve this. So the paychecks for professionals with big data skills are 40% higher than other IT skills. This is a report given by McKinsey, and it reports that it predicts that by the end of 2018 there will be a shortage of 190,000 big data professionals in the USA alone. So the demand is very huge, and you know. Uh, a lot of demand is for big data professionals. So clearly 2018 is the best time to upskill your career with more sought after big data skills. and get some training and master the technologies to make the best of what's like to become a long-term trend in IT. So there is every reason to learn the big data ecosystems. When I say big data ecosystem, we have big data, Hadoop ecosystem, meaning in the Hadoop ecosystem, we have tools to process the data. We have different types of tools for different purposes. Say Hadoop ecosystem, we have Yarn, which is yet another resource manager, negotiator, and then we have Pig, PigLatin is the tool of the language to develop it to process the data, to process huge volume of. And then we have MapReduce programs. You might have heard of these MapReduce programs. So here, the job of the program when you design an application, when you execute the program, uh, then the task is divided into subtasks, and each subtask is processed, and then we have reducer. So in the mapper section, the jobs and the tasks are reduced to subtasks, and each subtask is processed. And in the reducer, we have we combine all the results from the subtask and display the create a file or store the data. So MapReduce techniques, then we have MapReduce is basically based upon the Java. So if you are familiar with the Java, then you can easily do it. But some people, they may not be good at Java. Then instead of writing programs in Java using MapReduce techniques, they can use PigLatin, wherein it is similar to SQL. Actually, if you are familiar with this structured query language, you can process the data, you can read the file content, data file, and then you can process as if it is a database table, database data. Okay, so today we'll discuss about these things. HDFS, what is HDFS? Hadoop file system, we'll see, and Yarn, what is Yarn and how we can. I will give you the overview of these things, and also MapReduce, what we can do with MapReduce, PigLatin, and HBase. So Hadoop HDFS is nothing but Hadoop distributed file system. It is the world's most reliable storage system. So basically, this file system will help the user to store the data in a specific format. The format can be a text file or comma separated file or whatever may be the format appropriate. So you can store in that format and process that. And HDFS is a file system for Hadoop. It is designed for storing very large files running on a cluster of commodity hardware. Commodity hardware meaning a cheap hardware. It is not a very expensive. And say, for example, you have a desktop consisting of 1 terabyte of RAM and very small machine because it has commodity hardware, very inexpensive hardware. And it is designed on the principles of storage of less number of large files rather than huge number of small files. So instead of having huge number of small files, we have less number of large files and to process. Okay, and basically this Hadoop, if you look into the history, uh, Doug Cutting is the person who involved in the design and development of this Hadoop way back in 2004 or 5. So the idea started, in fact, when you Google for something within a fraction of microsecond, you will get all the data is dumped on your monitor. All the results are dumped on your monitor. So there are several lakhs of pages displayed immediately when you search for an item on Google. So the whole world was curious how how it happened, like how what is the technology behind it, what are the algorithms, and people are very curious and they started asking Google what is the idea behind that. So definitely it is a proprietary product. Google is proprietary product, so they don't want to reveal the uh, idea or the secret behind that. So instead of that, what they did, they presented a white paper in 2004, how they process the data and using MapReduce technique and all that. So based upon the technique, the duck cutting, a person from Yahoo, he started designing this Hadoop ecosystem. First of all, the challenge is we have to process huge volume of data. So data, as I told you, data is in the form of structured. So far, when you want to process the structured data, we call it as we take the help of RDBMS, Relational Database Management System, such as Oracle or from SQL Server from Microsoft or DB2 from IBM. So we have unstructured data and semi-structured. Semi-structured meaning we have both structured as some data is structured and some data is unstructured. So semi-structured data. So we have huge volume of data. What are the challenges with this volume of data? The thing is, first of all, we have to store the data. Once we store the data, then we have to process the data within a reasonable amount of time and manipulate the data. Say you want to update something or you want to delete unwanted records, etc. So modify the existing data. So within a finite range of data, it is possible we have machines and we have rack or NAS or SAN networks to store the data and process. It is possible for the structured data. Assume that there is a petabytes of data, terabytes. We have terabytes of data, then petabytes of data. So assume that we have tons of petabytes of data and we have to process it. First of all, the challenge is we have to store the data. And second thing is we have to process that stored data. And third one is modify the existing data. These are the challenges associated with the big data. So big data is a concept basically. So wherein big data means huge volume of data, huge volume, and we have huge volume of data as well as variety of data, we have to process. So there are 5 V's we have to process. So there are challenges associated with this huge volume of data or big data. So Hadoop is a solution. Hadoop is a solution for these things. Hadoop is a solution to process big data, big data problems. Okay, that's why we use big data concept. Big data, what is a Hadoop actually? Hadoop is a framework. It's a sort of an operating system. It is installed. It is an open source software, and we can install it on the top of Linux or Unix, on the top of Linux. So you should be familiar with the Linux commands. Like suppose you want to display the directory, ls is the command. You want to read the contents of the file, so cat is the command. Some preliminary commands on Linux, the same commands we use in Hadoop environment as well. Okay. Any questions here? All right. So we'll see Hadoop file system. We understood what is big data and what are the challenges associated with big data and what is the solution for big data. So it also provides this HDFS also provides fault tolerant storage layer for Hadoop and its other components. That means we have multiple copies of the same file stored in the HDFS system. So even in the case of a failure, the system will not stop executing the programs. Instead, it will go to the second node and get the data from there. So it also supports fault tolerant, and there is an advantage with the HDFS. And HDFS replicates of data helps us to attain this feature because of how we could attain this fault tolerance because of the replication of the data. So that means the data is stored in one commodity machine and it is replicated in other node. We call them as nodes, other nodes as well. So it stores data reliably even in the case of hardware failure and make sure that it ensures that the data consistency is maintained and reliability is also maintained. So it provides high throughput access to application data by providing data access in parallel. So parallelly you can access the data, same data in the case of failure. Okay. And how this can be, I mean, what is the structure of the HDFS? We call them HDFS nodes. Hadoop works in master-slave fashion. We have master server, master machines, and slave nodes or slave machines. So it has two types of nodes that work in the same manner. One is name node, we call them as name node, and data node in the cluster. So master is the name node and slave is like data nodes. So data is stored in the slaves. So if you look at the diagram, it looks like this. So we have master node where we have all the information related to regarding the slave nodes, where a particular data item, where a particular file is stored, in which node it is stored, etc. So in the master node, is having all the metadata information. Metadata means information about the data, where a particular file is stored, in which slave node it is stored, how many times it has been duplicated. All those details are stored in the master node. And in the slave node, you have the actual data. Name node regulates file access to the clients and it maintains and manages the slave nodes and assign tasks to them. Basically, the name nodes also assign tasks. When you submit a job for execution, so the name node will take care of that. It will instruct slave node to think of that. So name node executes file system namespace operations like opening a file and closing a file and renaming files and directories, etc. And data nodes, the slave nodes are also known as data nodes. And there are number of slaves or data nodes in Hadoop distributed file system. So the number of slaves, it depends upon the configuration. I mean, that depends upon the data and with what speed the data is entering into the system. So based upon those factors, so the data node has been designed, or slaves have been designed. So these manages the data storage, the data slave or HDFS slave or data nodes manage the data storage. And slave nodes are the actual worker nodes. We also call them as worker nodes because they do actual work of processing the data. So what these slaves do, they do the task and serve read and write requests from the file system's client and then process the data. So they also perform block creation and then deletion of the block or and replication upon instruction from the name node. So how many, say for example, a data file is replicated and how many times it should be replicated. So those details are done by data node. Block creation, it creates a block. So block means like in a specific block, how many bytes of information should be stored. So all those things are done by HDFS slave or data node. Once a block is written on a data node, so block of information is written on a data node, it replicates it to other data node and process continues until the number of replicas mentioned is created. So once the data is written in the data node, and it is replicated automatically and written into other nodes, other data nodes as well. So the replication factor, how many times it has to be written, that is given by the name node. The name node will instruct that. And data nodes can be deployed on commodity hardware or inexpensive hardware, and we need not deploy them on a very reliable hardware or expensive hardware. And in order to run these name nodes and data nodes, we have daemons, processes. There are two daemons which run for HDFS for data storage. So one is name node, another is data node. So processes are being run. Daemons means a process. So there are two processes running continuously on name node and data node. Name node means this is the daemon that runs on all the masters, and name node stores metadata like metadata means data about data, and it is like file name and the number of blocks to be written and number of replicas and the location of the block on the data node, etc. and block ID, etc. are stored in the name node. So this metadata is available in memory in the master for faster retrieval of data. So when you want to retrieve something from the data nodes, so what you have to instruct the name node will take care of that, and where is the location of the file, and all those details are there in the name node, and this information metadata, we call them as metadata. It is available in the name node memory for faster retrieval of the data. So in order to make it persistent, in the local disk also a copy of metadata is available, and then the same name node memory should be high. So name node memory should be high as per the requirement. So the memory requirement for name node is very high. Okay. Any questions here? So then next topic is yarn. What is yarn, and how uh, what it is? Let us see those things now. Yarn is like because it is from Apache, it is an open source. I mean, tool. Yet another resource negotiator. It is the resource management layer of Hadoop. So we'll see. And Yarn was introduced in Hadoop 2.x, and now it is Hadoop 3.x actually. So it has been introduced back in Hadoop version 2.6. What we can do with the Yarn? So Yarn allows different data processing engines like graphical processing and then interactive processing. That means when a program is run, you supply the values to the program, and then stream processing as well as stream processing means data is continuously is entering into the system. So we call them as streaming data, and you have to process such data. Okay. For example, you take Facebook as an example. Continuously data is entering to this Facebook system and in the form of pictures, videos, video clippings, messages, etc. And batch processing means all the programs are being compiled together as a batch and they are processed and to run and process data stored in HDFS. So you can also perform batch processing using yarn. So apart from resource management, yarn also does job scheduling. You can schedule the jobs when at what time the job should be executed, in what sequence the job should be executed. So you can also schedule the jobs. So it extends the power of Hadoop to the other evolving technologies such as HBase or Hive or etc. PigLatin. So they can take advantage of HDFS, and HDFS is the most reliable and popular storage system on the planet and economic cluster. And then MapReduce. This is the technique uh, we use to design the application, where the application will use this concept, MapReduce concept, to process the data. It is a core component of Hadoop, and it processes huge amount of data, huge volume of data in parallel. How it happens by dividing the work into set of independent tasks, and each task is executed, and finally the results of each task is combined together, and they call it as reducer. So it processes huge volume of data. So in MapReduce data flow in step by step from map to mapper to reduce. So in MapReduce we have a mapper and we have a reducer. So the data flow from mappers to reducer. So we'll be learning various phases of MapReduce job execution, such as input files and what are the different types and format of file, different formats of files, and then input format in Hadoop and input spreads. All these are the things we are going to discuss when you enroll in the course. Okay. So mapper, combiner, partitioner, shuffling and sorting, all these things happen, and reducer, and finally we have record writer and output format in detail. So basically the question is, what is a MapReduce? MapReduce is the data processing layer of Hadoop, simply states. So MapReduce is nothing but data processing layer of Hadoop. So it is a technique. So it is a software framework for easily writing applications which process the vast amount of structured and unstructured data that is being stored in the HDFS or Hadoop distributed file system. And how this MapReduce works? In Hadoop, MapReduce works by breaking the data processing into two phases. One is map phase and another is reducer phase. The map is the first phase of processing, and where we specify all the complex logic or business rules or costly code in the mapper section. Reduce is the second phase of processing, where we specify lightweight processing like aggregating the results of mapper and or summation of the mapper, and reducer will take care of that. So we have these different files. I'll skip this section. So do you have any questions here? PigLatin. PigLatin is an open source high level data flow system, and it provides a simple language called PigLatin for queries and data manipulation. So this is a helpful tool for non-Java programmers. Say, if you are a Java programmer, you can do MapReduce programs in Java, and if you are not good at Java, then PigLatin is the solution. So it is an abstraction over MapReduce actually. So it is a tool or platform which is used to analyze large sets of data, representing them as a data flows. So Pig is generally used with Hadoop normally. So we can perform all the data manipulation operations in Hadoop using Pig. So data manipulation operations such as insert, you want to insert a new value into the file, and you want to modify the existing value, existing data, or you want to retrieve the data. In such cases, we call it as data manipulation operations like DML, data manipulative language operations, such as insert, update, delete, and select. So these are our core things in SQL. So those things can be performed using Pig. So Pig provides a high-level language known as PigLatin, and then this language provides various operators using which programmers can develop their own functions for reading and writing the data and processing the data. So I will take an example. Uh, so basically, programmers need to write scripts using PigLatin language in order to analyze the data. So all these scripts are internally converted to map and reduce tasks automatically. You don't have to worry about all those things. When you submit the script, quick script, automatically it will be done. So I will just demonstrate one example, and before I conclude. So Apache Pig has a component called as Pig Engine, and this accepts the PigLatin scripts as input and converts those scripts into MapReduce jobs. So basically, the lab portion I have signed up for a cloud environment. So this is the cloud environment, and so uh, so this is the environment. Now, if I want to execute Pig programs, so I will simply type Pig error. This is the Linux system. See, this is my name is Tirunagari at this IP address. So this is the home directory. So we should get familiar with the Linux commands. Yeah, any questions here? Any questions? Okay. So the command to enter into Pig engine is Pig is the command. So enter. So I have two programs, one designed for. So this is the data, operation data I already loaded. So this is the data about population in the year 1850. So here one indicates it's a male, two indicates females. How many females are there within the range of age? So five, this is the age column, and this is the year column, and this is the male or female column, and number of people. This is the population count, number of people in that range. So within the age group of 10, the males are this. This is the count. This is the population count. So this is the file, data file consisting of all this information. Now we want to query, say for example, in 1850, how many females are there in the range 50 age group 50 above 50 or 55. So in that case, you can process this file, and you can write a query sort of thing in Pig, and you can achieve that. So I will just demonstrate this, and I will also use this file, program file. So I have written few commands. So I want to load. This is a population.csv. This is the file name, and I want to load the data and into a variable called population. So using pig storage as, and the data is in the form of comma separated value CSV format. So this is the format. What is the separator? And I also mentioned the columns, like year column is there, age column is there, gender, and population size. So this is the column. These are the columns available in the data file. So if you look at this, this is the year, this is the age, and this is the gender column, and this is the count, population count. So now the question is, in 1950, how many females are there uh, in the age group of 55, 50 to 55? We want to query that. So I will, these are the commands I write. So population is equal to load this one. I will copy this. So so this is a grunt shell. When I type pig, I will get this. I type pig here and I got this grunt shell. This is known as grunt shell. So here I can type pig commands. So I will copy this. So what will happen? I'm loading the file. Yes, that is successful. So no errors. So the data is loaded into this population variable. And now I called as population 55 female, filter population by age is equal to 50 and gender is equal to 2. 2 is indicates female, age is a equal to operator, that is equal operator. Age is equal to 50 and gender is equal to female. How many? What is the population count? So this is another variable. Of course, you can do it as a script as well. So this is also successful. Finally, you want to dump the data. You want to see the data. So it is being processed, right? So this is the data. Okay. So it says certain information. Total launch task 1, file bytes read 0, all these things. Actually, so these many bytes have been read because it is small file for our example. So then data is dumped here. Okay. Any questions here? So we have other tools like Spark is there. Spark is very popular, and Spark, Scala. Uh, in order to learn Spark, you need to understand Scala. So in the ecosystem, we have MapReduce programs. Then we have Yarn. Then Pig. Pig is for processing huge volume of data that is stored in the files. Pig or PigLatin I got as. Then we have Spark. So in order to learn Spark, we have Scala. Scala is a programming language, functional programming language, and that is a prerequisite for Spark. So these are the things we are going to discuss in our course with examples, the concepts, and how we can implement these concepts when designing an application. Okay. So I will stop here for today, and you have any questions, just let me know.
Thank you, Srinivasa. Thanks for the session. Audience, if there is any question, please use the chat button and do add your questions there, and the trainer would respond back to it. So we would give 5 minutes team. So any questions, please add in there, and Srinivasa would respond to it accordingly.
So are you able to hear me, Josna? Could you hear me, or you just mentioned? Can you speak a bit louder? Hello.
Yes, Srinivasa. I think yes, the audience was able to hear you. There are a few questions added on chat. If you see,
Yeah,
like
yeah, yeah.
yes, please go ahead.
What is the course curriculum? So, Ashna, didn't you share? I will also.
That's already.
Yeah, this is the course curriculum with data with Hadoop. And are you able to see this? Like, we have introduction, what is the big data, and what is the distributed system, etc. And then Zookeeper is a scheduler, like we'll also discuss about it. Actually, this should be the end of the course, but I put it in the beginning. So if you are already a working professional and you know how the jobs are scheduled, etc., then Zookeeper will be helpful. So I will shift to this to end of the course content. So then HDFS we'll discuss here what is a distributed file system, how we can configure basically, etc. All those things we discuss here. And the fourth chapter deals with yarn. Uh, what is we should not use the existing tools? Why we go for yarn? What is the reasons? What are the different reasons? All those things you'll see in this chapter. And MapReduce basics, so we'll understand the concept of MapReduce, and so we take an example, sorting example, and then word frequency problem without MapReduce. So how does it look like? Suppose an example we'll see. Also, you want to image resize resizing an image. So some examples we'll take up and discuss the basics of MapReduce. And in the sixth chapter, we discuss about advanced concepts in MapReduce using Java, using AND, etc. So uh, then we'll see some examples. And then the seventh chapter, we deal extensively with the PigLatin or analyzing data with the pig. And in the eighth chapter, we deal with Hive. Hive is for database. It is a business intelligence BI tool. Like so, what are the different data types, etc. All those things we'll see how we can process the data with the Hive in the eighth chapter. And in NoSQL and HBase, we'll review introduction to NoSQL and HBase architecture in ninth chapter. And 10th chapter deals with importing data to the system from external source using Scoop and Flume and Oozie. These are the tools for importing the data. So we will see how we can do that with examples. Okay. And 11th chapter deals with the Scala, fundamentals of Scala. So this is a prerequisite for Spark. Spark is a popular tool for data applications. So, and the 12th chapter was dealing with Spark. Spark. Okay, this is the content. Project. Of course, I have been taking. I will be explaining a lot of examples. So, okay, okay. So, is it okay now? My voice is okay, and you have any other questions? Hello. So normally it is designed for 35 hours. The entire course is being designed for 35 hours. 35 to 40 hours approximately. Okay. Any more questions or? All right. I'll conclude here. And Ashana, okay, thank you. And I'll stop here for today's discussion. And have a great one. Thank you very much. Thank you all, and have a great one. Bye bye.